Today we are going to discuss electric charges and electric fields. In that chapter, all derivations we are going to discuss in one episode. Let us see, my dear students, electric charges and fields. So first one is Coulomb's law. Coulomb's law. If I am going to consider 2 point charges separated by a distance r, so the force between the 2 point charges is directly proportional to product of charges, and force is inversely proportional to square of the distance between those two charges. What is the meaning of that? If I am going to consider two charges q1 and q2, these two are point charges, meaning the separation between the two charges is very large when compared to the size of the charges. At the time, these charges we call it as point charges. If the distance between the 2 point charges I am going to consider r, so the first one is force between the two charges is directly proportional to charges. What is the meaning of that? If at least one of the charge magnitude increases, force will increase. That is the meaning of force is directly proportional to product of charges. Here force is inversely proportional to square of the distance between the two charges. This is the second one. By combining these two, we are going to get q1 times q2 upon r square. By replacing the proportionality symbol, we are going to get one is equal symbol, and here one constant will come into q1 q2 by r square. This is the force between the two charges. Here k is the proportionality constant and it is equivalent to 4 pi epsilon naught, and its value is 9 into 10 power 9. 9 into 10 power 9. And its k unit is Newton meter square per Coulomb square. Newton meter square per Coulomb square. So this is about Coulomb's law. While solving the problems, my dear student, remember 1 by 4 pi epsilon naught, replace it 9 into 10 power 9. So here k is the proportionality constant and it has the unit, and its unit is Newton meter square per Coulomb square. Why? Because from here I am going to write k is equal to what? Force distance square upon q1 q2. These two are equivalent. Then what is the unit of k? Force measured in Newton, distance measured in meter, so meter square upon Coulomb into Coulomb, Coulomb square. That is only every time. So this is about Coulomb's law. The next one, my dear student, just pause it and note down. Electric field. Electric field strength. Suppose I am going to consider a point charge which is at a distance r. What is the meaning of point charge here? And compared to point distance from the charge is a very large than the size of the charge. At the time we call it is a point charge. So if I am going to consider a point charge at a distance r, what is the electric field at this point? At the time, I need to consider a unit test charge at this point. What is the force acting on the unit test charge placed at that point is called electric field at that point because of this charge. Because of this charge. That means how to define the electric field? Force acting on unit test charge or simply test charge placed at this point, we call it as electric field strength because of this charge at this point. I'm going to repeat. What is the electric field? Force per unit test charge placed at that point is called electric field of discharge at this point. Right. We are going to calculate electric field due to point charge. How to calculate? Let us see. Electric field due to point charge. Let us see. This is the electric field. What is the force at this point on the unit test charge? K into product of the two charges, Q times Q naught by distance square upon Q naught. Q naught cancel. Then what is E? K into Q by R square. This is the electric field formula. This is the electric field formula. Already we discussed with my students. K means 1 upon 4 by epsilon naught. Don't forget. So this is the electric field formula. K into Q by R square. K into Q by R square. What is the meaning of this? If I am going to consider a charge Q and at a distance R, I require electric field because of this charge. Then what is the electric field strength at this point because of this charge? How to calculate? 1 upon 4 pi epsilon naught this charge by this point distance from the charge, square, distance square. Square of the distance of the point from the charge. That is R square. That's all, my students. That's all. This is the electric field strength because of point charge at a distance R from the charge. Note down. Next one, electric dipole. Electric dipole. So what is electric dipole? Consider two equal and unlike charges separated by a small distance. That arrangement generally we call it as electric dipole. If I am going to consider a positive charge and a negative charge, equal and unlike charges. Both are separated by a small distance. So from center to negative charge distance L, from center to positive charge distance L, and separation between the two charges is 2L. This arrangement generally we call it as dipole. So next we are going to discuss about electric field due to dipole. Due to dipole. So I am going to consider first one. There are two different cases. One is electric field due to a dipole at a point on its axial line. So we are going to calculate electric field due to a dipole at a point on its axial line. That means I am going to consider first dipole. One is a negative charge, another one is a positive charge. This is the separation between the two charges, that is 2L. From center to this point is L, from center to negative charge is L. So this is L and this is L. And here I am going to calculate. Here what is 2L? Total length is 2L. Here I am going to consider axial line. Axial line of a dipole. On the axial line, that means on the axis of the dipole. So I am going to consider a point X. At the point X, I need to calculate electric field strength because of this dipole. So I am going to consider dipole consists 2 point charges. One is plus Q and the one is minus Q. Already we know that what is the electric field because of a point charge? K into charge by distance square. So what is the electric field because of positive charge at this point? That is I am going to consider E1. This is I am going to consider charge 1. This is I am going to consider charge 2. Electric field because of charge 1, that is positive charge. So K into Q by Distance square. What is the distance of the point from this charge? My dear student, I am going to consider a point x at a distance r from the dipole. From the dipole means I need to consider from the center of the dipole. That is r. That is r. Then what is the distance of the point from the plus q charge? This distance. From here to here r, from here to L, I need to calculate this distance. From the r, subtract L, you are going to get this distance. From the r, subtract L. Then from the r, subtract L, you are going to get this distance. That is the distance of the point x from the positive charge. Then I need to write distance square. Distance square. So E1 into electric field because of first charge, that is positive charge. K into Q, this magnitude, by distance square, that is R minus L whole square. That is the E1. How to calculate E2? E2 means because of second charge, that is negative charge. So K into, what is the magnitude of the charge? Q by, what is the distance of the point from the second charge, that is negative charge. So from here to center R, from center to negative charge is L. Here to R, and from here to negative charge is L. That is R plus L. So distance square means R plus L whole square. R plus L whole square. So this is the magnitude of electric field because of first charge at point x. This is the magnitude of the electric field because of second charge at point x. Now electric field is a vector quantity. We have the directions. My dear student, one thing you are going to remember, these are the formula to calculate magnitude. While calculating magnitude, in case of vector quantity, don't substitute the negative symbols in the formula. Why? Because we are going to using the negative symbols to represent directions in the diagram. So here I am going to consider electric field. What is the electric field because of this negative charge at this point x, and what is the electric field because of positive charge at this x? We need to mention the directions. Because of positive charge, what is the electric field direction here? So remember my dear student, you are going to imagine a unit positive charge. Imagine a test charge. What is the meaning of test charge? Unit positive charge. Unit positive charge. So this test charge is always positive charge only. Positive charge only. So to identify the direction, you are going to imagine unit test charge at that point. It is very easy. So if I am going to imagine a unit positive charge at this point x, why? Because I need to calculate electric field at x, then I need to imagine a unit positive test charge at x. Then that because of positive charge, in which direction the test charge will move? Away. Why? Because repulsion force. Because of repulsion force, the test charge move away. That is the field direction. That is the field direction at point x. Because of positive charge. Because of positive charge, that is the E1 field direction. So because of negative charge, what is the field direction? Towards. Why? Because unit test charge moves towards the negative charge because of attraction. That's why this is the field direction E2. E2 is the field direction because of negative charge. E1 is the field direction because of positive charge. Because of positive charge, field is away from the point. Because of negative charge, field is towards from the point towards the negative charge. E1 and E2 both are opposite and their magnitudes are E1 and E2. Which one is greater? So here plus charge is near to point. That's why E1 field dominates. That is E1 is greater than E2. Then both are in opposite direction. Then what is the net field? E1 minus E2. So I need to calculate E1 minus E2 now. What is E1? K into Q by R minus L whole square minus what is E2? K times Q upon R plus L whole square. Now take the KQ common. Then inside what remains? 1 upon R minus L whole square minus 1 upon R plus L whole square. My dear student, net electric field is equal to K times Q into After simplification, what we are going to get? Here 4 times RL upon. This is the mathematical simplification, students. No need to do the simplification. Don't waste our time. Just write down 4 times RL upon R minus L whole square into R plus L whole square. No. So 1 by R minus L whole square minus 1 by R plus L whole square. How we are going to get? 4 times R into L, and in denominator R square minus L square whole square we are going to get. R square minus L square whole square we are going to get. Then E net is equal to K times Q. 4RL I am going to written as 2R into 2L or 2L into 2R. 4RL just split in this manner upon R square minus L square whole square. Then E net is equal to, observe here, K into Q into 2L. Q into 2L, that is the dipole moment. Q into 2L, dipole moment. We call it as Q into 2L is the dipole moment. Dipole moment P is equal to Q into 2L. Remember, my students. And this is the 2R by R square minus L square whole square. Then finally, E net is equal to, how much I am going to get? K into 2PR. 2PR upon R square minus L square whole square. So this is the net electric field at any point on the axial line of a dipole. Note down, students. For short dipole, when we call it as short dipole, suppose my distance of the point from the dipole is very much greater than L, we call it as short dipole. So in this situation, E net is equal to, at any point x, K into 2PR. L is negligible. Automatically L square is also negligible. Then R square whole square. Then E net is equal to K times 2 times P times R upon R to the power 4. R get cancelled in R to the power 4, R cube times. And finally, what is the E net we are going to get? Simply K into 2 times dipole moment upon R cube. This is the E net. What is K here, my dear student? 1 upon 4 pi epsilon naught. Its value is 9 into 10 to the power of 9 SI units. Right. Note down. Now, electric field due to dipole at a point on its equatorial line. Suppose I am going to consider a dipole, electric dipole. That means this is the negative charge and this is the positive charge separated by a distance 2L. This is the 2L. And this is the center. I am going to consider a point. So what is the equatorial line first of all? So any line passing through center of the dipole and perpendicular to axis, that is the equatorial line. Any line passing through center and perpendicular to axis of the dipole. That line is called equatorial line. Here this is the equatorial line. I think you can understand what is the equatorial line. Now I am going to start derivation. So we need to calculate electric field due to dipole at a point on its equatorial line. Let us see. I am going to consider this is the negative charge and this is the positive charge. Both are separated by distance 2L. That means from center to positive charge is L, that means this distance is L from center to negative charge distance is also L. Now these are the two charges. Now this is what? Equatorial line. This is what? Equatorial line. Equatorial line. Right. I am going to consider a point Y. A point Y at a distance R from the center of the dipole. That means from the dipole. Here I am going to consider a point. What is the electric field because of negative charge at this point? Remember, we need to join the point and charge with a straight line. With a straight line like this. Electric field is always along the line joining the charge and point. If it is a negative charge means electric field direction towards the charge. Towards the charge. Similarly, along the line joining point and charge and towards the charge electric field because of negative charge. Here what happened? Point and charge just to join. Just to join. And here what is the electric field? Along the line joining only, but this is the positive charge, from the point away from the charge. So this is the charge. This is the charge, positive charge. Because of this positive charge, what is the electric field at this point? Along the line joining away from the point. Away from the, so from the point we need to draw a line away from the charge. I am going to repeat. Because of this charge, what is the electric field at this point? We need to draw electric field line along the line joining charge and point away. Why? Because this is the positive charge. Now, this is I am going to consider first charge. This is I am going to consider second charge. Because of first charge, what is the electric field? This one. That is considered E1. Because of second charge, what is the electric field? E2. Consider E2. So, what is the E1 now? What is the E1 magnitude? K into Q upon distance square. What is the distance of this point Y from the charge? From the charge. This is L, no? This is R. Then this is like in this right angle triangle. In this right angle triangle, this is the hypotenuse. Then root of R square plus L square. Then what is the distance square? Root of R square plus L square whole square, distance square. Distance of the point from the charge is root of R square plus L square. Here distance square. That's why distance square. Square root cancel. Then what is the E1? E1 is equal to K times Q upon R square plus L square. Similarly, what about the E2? E2 also, what is the distance of the point from Q? This is L, this is R. In this right angle triangle, this is perpendicular, then this is the hypotenuse, then what is its value? R square plus L square. So, what is the E2? K into charge is Q by what is the distance square? Root of R square plus L square is the distance. Then distance square means square root cancel and we are going to get R square plus L square. That is E2. So, E1 magnitude and E2 magnitude both are same. E1 magnitude and E2 magnitude both are same. My dear student, this is the magnitude formula. You substitute while calculating magnitude of electric field. Only substitute the magnitude of the charge only. Don't substitute negative symbol in the formula while calculating magnitude of electric field. This negative symbol we are going to using to represent the direction. By using this symbol only, I am going to give a direction of the electric field at this place. That means the negative symbol already I used. Don't use once again in this formula. So here what happened? E1 is equal to E2 by observing E1 and E2 values I given here. This is the condition. Both are equal. E1 and E2 both are equal. And what is the angle between the E1 and E2? Suppose I am going to consider this is the angle theta. Suppose this is the angle theta. Then this is what? A parallel line. This is what? A parallel line to this base or to this length of the dipole. This line is the parallel to length of the dipole. and this is act as a transversal. If it is theta means this is also theta, then it is also theta. Then what is the angle between the two electric fields? This is E1, this is E2. What is the angle between them? The total angle is 2 theta. That is the angle between the two electric field vectors. So E1 is equal to E2, I know that. E1 is equal to E2. I am going to consider E1 is equal to E2 is equal to some electric field E. Now I need to calculate net electric field at point Y. That is I am going to consider Ey. How to calculate? Root of E1 square plus E2 square plus 2 E1 E2 cos theta. Cos theta. What is theta here? Angle between the two electric field vectors E1 and E2. That is 2 theta. That's why I am going to write here 2 theta. Why? Because angle between the E1 and E2 is 2 theta. That's why. This is the formula to calculate electric field vector. Why? Because electric field is a vector quantity. E1 square E2 square plus 2 E1 E2 cos theta. Where theta is the angle between the two electric fields I need to write. Here what is the angle between the two electric field vectors? 2 theta. That's why I am going to write 2 theta. Now Ey is equal to E1 and E2 both are equal now. That is I am going to consider E. That's why E square plus E square. E square plus E square. 2E square. Plus 2 E1 into E2. 2 into E. Why? Because E1 and E2 both are equivalent to E. Both are same and I consider as a E. Then E1 into E2 means E into E square. So 2 into E square cos 2 theta. In next step, I am going to take the 2E square common inside the root. Then what remains in the first term? 1. After taking 2E square as a common, what remains in the second term? Cos 2 theta. And already we know that 1 plus cos 2 theta means we have the formula. 1 plus cos 2 theta means we have the formula 2 cos square theta, trigonometric formula. That formula I am going to use in here. Then Ey. Then Ey is equal to square root of 2 times E square times 1 plus cos theta. 1 plus cos 2 theta value 2 times cos square theta. Now Ey is equal to 2 into 2 4. Bring out as a 2 and E square bring out as a E from the root. And cos square theta bring out here E square, just bring out as a E from the root. Now cos square theta as a cos theta. So 2 into 2 4, bring out as a 2, E square as a E, cos square theta as a cos theta. Just this is what Ey is equal to 2E cos theta. 2E cos theta. Now Ey is equal to 2 into what is E? E1 and E2 both are equal and I consider E. So take the E1 value or E2 value. Why? Because both are equivalent only. So E1 and E2 both are equal. That is I consider as a E. Then what is the E value? Take the E1 value. K into Q upon R square plus L square. R square plus L square into cos theta. What is the cos theta from the figure? My dear student, from in this figure, what is the cos theta? Adjacent side by hypotenuse. I am going to repeat. In this triangle, what is cos theta? Adjacent side by hypotenuse. Adjacent side is L. Hypotenuse is root of R square plus L square. So cos theta means adjacent side. Cos theta means adjacent side L. Hypotenuse root of R square plus L square. So finally we are going to get Ey is equal to observe here K into Q into 2L. Q into 2L upon R square plus L square root of R square plus L square. That is R square plus L square whole power 3 by 2. So finally Ey is equal to what? K into Q into 2L. Q into 2L means dipole moment. Q into 2L means dipole moment P. So P by R square plus L square whole power 3 by 2. That is the electric field due to a dipole at a point on its equatorial line. Note down, students. What the value we got? Electric field on the equatorial line of a dipole, K into dipole times R square plus L square whole power 3 by 2. Suppose for short dipole, Ey is equal to K into P upon. For short dipole means what is the meaning? R is very much greater than L. Then L is very much small. Then L square is negligible. Then what is the denominator? R square upon whole power 3 by 2. K times P is the dipole moment upon R square. L square is negligible. Just remove it. R square whole power 3 by 2. 2 cancel out. Ey is equal to K times P by R cube. So this is the electric field because of short dipole, where K is equal to 1 upon 4 by epsilon naught. That's all, my dear students. Note down. My dear students, electric flux concept, and it is represented with a symbol pi. So electric flux means the number of field lines crossing surface normally. Electric flux means what? Electric flux means the number of field lines crossing a surface normally. Generally we call it electric flux. If I am going to consider electric flux for a small surface, electric flux formula for a small surface is E bar dot ds bar. It is a dot product, no? That's why it is also we are going to written as E ds cos theta. For the closed surface, what is the flux? For a closed surface, what is the flux? E bar dot ds bar. E bar dot ds bar. So it is also can be written as E ds cos theta. From the Gauss law, what is the electric flux? So according to Gauss law, electric flux is defined as in any closed surface, the flux passing through any closed surface is 1 upon epsilon naught times the net charge enclosed in a closed surface. So what is the electric flux according to Gauss law? According to Gauss law, electric flux we are going to define as the electric flux through any closed surface is equal to 1 upon epsilon naught times the net charge enclosed in it. The net charge enclosed in it. That's why this is the electric flux formula. These are the electric flux formulas, my dear student. Just remember. So we have some applications based on electric flux concept, that is Gauss law concept. We will see one by one. First application, electric field. These are all Gauss law applications. So electric field due to a infinitely long straight wire. So electric field due to a infinitely long straight wire. If I am going to consider a straight wire, it has a charge. I am going to consider, let lambda be the linear charge density. Linear charge density. What is the meaning of that? Charge per unit length. Charge per unit length. That is the meaning of lambda. Charge per unit length. From here, what is the charge? Linear charge density into length. Linear charge density into length. Here, I am going to consider a linear charge of charge density lambda. I need to calculate what is the electric field because of this infinitely long straight wire. This is I am going to consider infinitely long straight wire. So I am going to apply the Gauss law. I need to consider a Gaussian surface. Suppose I need to calculate electric field at this point. So I need to consider Gaussian surface passing through this point like this. This is the Gaussian surface passing through this point. I need to calculate electric field at this point. How to calculate? How to calculate? Let us see. The distance of the point from the linear charge density is R. So here there are three surfaces. This is the first surface. This is the second surface. That is the top surface, flat surface first. Second, bottom surface, flat surface. And third one is curved surface, 3. Totally 3 surfaces. What is the flux through first surface? We have the formula E bar dot integral E bar dot ds bar. That is E ds cos theta. Directly write down. E ds cos theta. Here, from the positive charge, field direction away. This is the field direction. From the positive charge, field direction is away. This is the field direction at this flat surface. And ds value, I am going to consider a small ds here. On the total flat surface, consider a small ds. And what is the ds here? ds direction, area vector direction, always normal outward drawn to the surface. So normal outward drawn to the surface is the area vector. So this is the area vector. Then what is the angle between ds bar vector and e bar vector? 90. Then theta is 90. Then cos 90 value 0. Here theta is 90. Then phi 1 is equal to E ds cos 90. Cos 90 value 0, no? That's why phi 1 0 over. What about phi 2? The same explanation like here. We are going to explanation same as surface 1. Then pi 2 also 0. Then what about the pi 3? Pi 3, curved surface area. So consider a small surface here on the curved surface. That curved surface area vector, a line or a normal drawn outward. That is the ds bar vector. What is the electric field vector? So electric field vector is also in the same direction like this. Why? Because electric field direction away from the wire. Why? Because positive charge wire. So electric field vector, ds bar vector, both are in the same direction, means parallel vector. Parallel vector means theta 0. At the time, integral E ds cos 0. E ds cos 0. Cos 0 value 1. Then phi 3 value integral E ds. E is a constant. Take out. Then ds. Then E into, what is the integral ds? Integral ds. That means This is the ds means small surface area, considered small surface area. ds means related to this small surface area, what is the total surface? I'm going to consider this small surface area on the curved surface area of the cylindrical surface, curved surface. Then I'm going to consider ds is on the curved surface area of a cylinder. That's why integral ds means I need to take the total curved surface area. What is the total curved surface area? 2 pi rl. Suppose its length is L. I consider the cylindrical length is L. Then what is the total ds? 2 pi rl. That is the total curved surface area of the cylinder. Cylinder curved surface area formula, that one. Then pi 3 value I got how much pi 3? Pi 3 is equal to 2 times pi rl into E. 2 pi rl times E. That's all. So total curved surface area into E. That is the pi 3. Then what is the total flux? What is the total flux? Pi 1 plus pi 2 plus pi 3. Then pi is equal to pi 1 0. This is pi 1. Pi 2 0. 0 plus 0. What about pi 3? 2 pi rl times E. So finally, what is the flux I got? 2 pi rl into E. This is the flux. Consider equation 1. Consider equation 1. Note down, students. Now, according to Gauss law, what is flux formula? Q net. That is only I'm going to write Q. Here Q means Q net only. Q means what? Q net only. Okay, right. Q net upon epsilon naught. This is considered 2. From equation 1 and 2. From 1 and 2. This is pi, this is pi. Then equate right hand sides. Equate right hand sides. That is 2 pi rl E is equal to Q upon epsilon naught. Then 2 pi rl transpose to other side. Then E is equal to Q by 2 pi rl into epsilon naught. What is Q? Lambda into L. What is Q? Lambda into L. Lambda into L by 2 pi rl epsilon naught. L cancel out. Then what I am going to get? E is equal to finally lambda upon 2 pi r epsilon naught. 2 pi r epsilon naught is the final result we require. This is the electric field due to a infinitely long straight wire. E is equal to lambda by 2 pi r epsilon naught. Hence proved. That's all. Note down, students. Second application. Electric field due to an infinite plane sheet. So I'm going to consider an infinite plane sheet. And I'm going to consider let sigma be the surface charge density. What is the meaning of that? Sigma is equal to charge per unit surface area. Charge per unit surface area. From here, what is Q? From here, what is Q? A transpose to sigma z. Sigma times A. Now, to calculate electric field because of this infinite plane sheet, consider a Gaussian surface like a cylindrical. So suppose I need to calculate at this point, means I need to consider a Gaussian surface, closed surface passing through that point. So I'm going to imagine a Gaussian surface like this. Here also three surfaces. This is the flat surface 1, this is the flat surface 2, this is the curved surface 3. Curved surface 3. So on the flat surface I am going to consider a small ds. Here also I am going to consider a small ds, and here also I am going to consider a small ds. Now flex 1 pi 1 because of flat surface 1, integral E bar dot or EDS cos theta. EDS cos theta. What is the theta now here? Let us see. Area vector outward normal drawn, that is the area vector. Area vector. Here you are going to consider surface area A or S. Why? Because I consider here surface area as S, no? That's why I'm going to consider here also S only. So charge per unit surface area. So sigma is equal to charge per area. S means surface area. So surface area transposed to sigma z. Then what happened? Sigma S. Consider all symbols. If you want to consider here A means you are going to consider here dA. Here ds you are going to consider means here also consider S. That's all. Pi 1 is equal to integral EDS cos theta. EDS cos theta. Here what is the theta? Angle between E and ds at this surface. What is the ds direction? ds is a vector quantity, area vector. What is the ds area vector direction? Outward normal drawn at this point. What is the field direction? Positive charge, no? Positive charge means away from the plane sheet like this. Now E bar vector direction, ds bar vector direction, both are same. Then theta value 0. Then cos 0 value 1. Theta value 0. Then cos 0 value 1. Its value is 1. Then what is flex pi 1? E take out constant, integral ds. Then pi 1 is equal to E into integral ds means what? Total surface area. Total surface area. That means yes, integral ds value, yes, total surface area, yes. That is pi 1. What about the pi 2? What about the pi 2? Pi 2 also same flat surface and the same explanation, we are going to get ES only. So pi 1, pi 2, both are flat surfaces, same flux only we are going to get. What about the pi 3? What about the pi 3? Curved surface area. So here what is the area vector? Outward normal drawn. So this is the radius means along the radius from the area outward normal will give the area vector. That is ds bar. What is the electric field vector? This is the positive charge, no? Away from the positive charged plane sheet like this. This is the E bar vector. This is the E bar vector. This is the ds bar vector. Both are perpendicular. Then what is the angle between the E bar and ds bar? 90. That's why E bar and ds bar, angle between these two is 90. Then integral E ds cos theta. Here cos theta 90, no? Theta 90. So cos 90 value 0. Theta 90. Why? Because here ds value along the radius from the ds surface to outward normal drawn. That is the ds bar. What is the electric field? Away from the positive plane sheet. These two vectors are perpendicular. Then theta 90. Cos 90 value 0. Cos 90 value 0. That's why it is 0. Then flex pi 3 is also 0. Then what is the total flux we are going to get? Pi 1 plus pi 2 plus pi 3. So pi is equal to, what is pi 1? Es. Pi 2 Es. Pi 3 0. Then what is the total flux I got? Es plus 0. 2 times E times S. This is considered equation 1. Note down, students. According to Gauss law. According to Gauss law. What is the flux? Charge enclosed by epsilon naught. Consider this is the 2. From 1 and 2. From 1 and 2. This is also flux. This is also flux. Then right hand sides are equal. Then 2Es is equal to, here right hand side is 2Es. Here right hand side is Q upon epsilon naught. So 2Es is equal to, what is Q here? Q means sigma S. What is Q? Sigma S. So sigma S upon epsilon naught. Both sides SS cancel, surface areas. Then 2E is equal to sigma by epsilon naught. I required E. 2 transpose to other side. Sigma upon 2 epsilon naught. This is the electric field due to an infinite plane sheet, my dear students. Hence proved. Here this formula does not have distance, the physical quantity distance. That's why, my dear student, remember, electric field, because of infinite plane sheet of charge, it does not depends upon the distance. Why? Because at all points, here and here and here and here, consider near to plane sheet at any point, electric field magnitude is same only, sigma by 2 epsilon naught. Hello, good morning, students. This is our Jayesh Kumar Bandaru. This is especially for Cbse plus 2 students. I am going to do 14 episodes to complete the complete Cbse physics chapters. So each chapter I am going to release as a one episode. In one episode I am going to explain complete one chapter, and I am going to release one episode for each day. So my dear students, follow the 14 episodes to score good marks in physics in our board exams, Cbse board exams. Don't forget, my dear student, and don't miss it to watch all 14 episodes to score the good marks. And also, if you like this video, don't forget to subscribe, share and like, my dear student. So I am going to